In this video, I will explain how to use dimensional analysis to convert from one unit to another. For these problems, I always follow the same steps. First, I start with the measurement given on the far left. I show how I'm multiplying by a conversion factor as a fraction. I cancel out the units in the numerator and the denominator, and then I show the correct final answer on the far right with the correct units. Here's a problem that asks to convert 5.46 grams into milligrams. So I start by writing out 5.46 grams on the far left. Then I multiply by a conversion factor as a fraction. Because grams is in the numerator on the left, it will also go in the denominator on the right as part of my conversion factor. I put milligrams into the numerator because that's what I want to convert into. I use the fact that 1 gram equals 1,000 grams to do this conversion. I put 1,000 next to milligrams and 1 next to grams to complete my conversion factor. The unit grams crosses out because it's in the numerator and the denominator, and I need to multiply 5.46 by 1,000 because they're both in the numerator. Whenever something's in the numerator, we'll multiply. If something's in the denominator, we'll divide. 5.46 times 1,000 equals 5,460, and that's our final answer. Let's look at another problem that asks us to convert 0.0184 liters into centimeters cubed. Again, we start by writing the measurement on the far left. Then, we multiply by a conversion factor. Since liters is in the numerator on the left, it needs to go in the denominator on the right. This is so that unit cancels out. We need to convert into centimeters cubed, so that unit goes in the numerator of the conversion factor. Since 1 liter equals 1,000 centimeters cubed, we'll put those numbers in our conversion factor. Again, we multiply what's in the numerator. 0.0184 times 1,000 comes out to 18.4 centimeters cubed. Now let's try a problem that asks us to convert 810.5 centimeters cubed into meters cubed. We start by writing the measurement on the far left, 810.5 centimeters cubed. We multiply by a conversion factor with centimeters cubed in the denominator. This is so centimeters cubed cancels out. Since we want to convert into meters cubed, that unit goes in the numerator. 1 meter cubed equals 1 million centimeters cubed. 1 will go next to meters cubed in the numerator, and we can abbreviate 1 million as 10 to the 6 in the denominator. Since 10 to the 6 is in the denominator, we're actually going to divide this time. So 810.5 divided by 10 to the 6 equals 0.0008105. Now, we'll try a problem that has units with a numerator and a denominator. These are units of density. This problem asks us to convert 0.951 grams per centimeters cubed into kilograms per meter cubed. As always, we start by writing the measurement 0.951 grams per centimeter cubed on the far left. Then, we multiply by a conversion factor. In this case, I have to choose whether to convert the numerator first or the denominator. I'll start with the numerator. Since grams is in the numerator, I'll put grams in the denominator of my conversion factor. Since I want to convert into kilograms, I'll put that in the numerator. Since 1 kilogram equals 1,000 grams, I need to put those numbers in the conversion factor. 1 will go with kilogram, and 1,000 will go with gram. Just like in the previous problems, gram will cancel out. What makes this problem different is there's an additional step since I have to convert the denominator into meters cubed. Unlike the other problems, I actually need to put centimeters cubed in the numerator so that it cancels out with the denominator on the far left. I also have to put meters cubed in the denominator because I don't want it to cancel out. Those are the units I'm trying to convert into. Since centimeter cubed is in the denominator and the numerator, it cancels out, leaving only meters cubed in the denominator. Since 1 meter cubed equals 1 million centimeters cubed, I'll use that in my conversion factor. I put 10 to the 6 next to centimeters cubed and 1 next to meters cubed. Again, if something is in the numerator, we multiply. If something is in the denominator, we divide. So for this problem, I'll do 0.951 divided by 1,000 times 1 million. And the final answer is 951 kilograms per meter cubed. To end, we'll do one more problem with density units that has both a numerator and a denominator. The units that go on the far left are 5.3 milligrams per decimeter cubed, and we want to convert that into grams per centimeter cubed. I'll start by multiplying by a conversion factor that has milligrams in the denominator so that milligrams crosses out. Then, I put grams in the numerator because those are the units I want to convert into. 1 gram is equal to 1,000 milligrams. So 1 will go next to gram, and 1,000 goes next to milligrams. Now to get rid of decimeters cubed in the denominator, I need to put it in the numerator of my next conversion factor. This is so that decimeters cubed crosses out. Since I want to convert into centimeters cubed, that goes in the denominator. 1 decimeter cubed is equal to 1,000 centimeters cubed. 1 will go next to decimeter cubed, and 1,000 will go next to centimeters cubed. Again, if something is in the denominator, we need to divide. So for this problem, I'll do 5.3 divided by 1,000 divided by 1,000. My final answer is 0.000053 grams per centimeter cubed. There you go. That's how you use dimensional analysis to convert from one unit to another.